My name is Jen Weber, and I'm an engineer at Cardstack. Today, I'm going to be working on converting one of the Cardstack packages to TypeScript. This is a new development in our codebase to try and move towards TypeScript, which we're doing so that we can refactor more quickly and overall improve the strength of this JavaScript repository. It is something that the Ember.js repository uses. A lot of the other engineers outside of Ember are huge fans of TypeScript, and I, thought it was pretty cool the first time I used it, but have really seen over the past couple of days what the powers are once you've got it all set up. So I'm going to walk through finishing up a pull request that I'm making to convert one of Cardstack's internal packages into TypeScript. So first thing I'm going to do is open up the Cardstack monorepo here, which has a ton of directories inside of packages. Packages are kind of plugin based functionality for a lot of core Cardstack features. For example, there's an ephemeral database that's like a caching layer between your application and maybe, you're integrating with a really slow enterprise database system or something like that. This caching system can mean that your application is really fast because it's kind of prefetching some of that data. Another example is image, which is a Cardstack card that lets you upload and save images to S3. Let's see, what are some of the others here? There's S3 itself. We've got something called edges. Edges are those really beautiful animations that you might have seen in some past Cardstack demos where, the right-hand side panel comes in and you can actually make changes live to an app or a blog post or something. It's basically your editing tool set. So today I'm going to be working actually on something called DI, which stands for dependency injection. It's really just a small utility within the overall Cardstack repository. It's mostly, the sort of thing that gets used internally and referenced by a lot of other parts of the Cardstack hub. So what I've done here is I've already started on this one. You'll notice that the extension here is .ts, standing for TypeScript. So the first step to converting something to TypeScript is just to, instead of naming it index.js, to name it index.ts. Once you've changed a file name, your VS Code should probably pick it up after you've installed ESLint TypeScript as well. If you don't see that happen, just kind of restart your VS Code if that's the IDE you're using. But also in the background, I'm going to run a TypeScript compiler. So in this repository, I can do that with yarn compile watch. The watch means that as I'm making changes to my code, the compiler is going to notice when there are problems and tell me about them. I can see them here. As well as its job is to take the TypeScript file and compile it into regular JavaScript, which our app can use. I'm not going to be touching these files here. These are kind of dynamically generated by the compiler based off of my index.typescript file. So I've already done a little bit to convert this one, but I'll show you some about what it looks like as you're going through. So let's see, where did I? For example, this lookup function, which is on our container class, if I take away my type that I've put here, I can see here parameter specifier implicitly has any type. So TypeScript expects you to tell it what type of arguments are going into a function, as well as what type of arguments are coming out. So any literally means any, but if you know what the type is, you can kind of fill that in. So once I have put string here, now it is reflected that no more errors. If I go down here, of course, I still have a bunch more to work through. I find it's pretty helpful to look at a cheat sheet from time to time. I actually really like this one. It's very easy to search and look at, but there's tons of them out on the internet. So I haven't used TypeScript in about 2 years. I worked in it for about a week or two and have forgotten almost everything except for some of the mental models. And the mental model is that everything in your code needs to declare its type, whether it's a string, boolean, array of strings, etc., or maybe you're just going to say it can be anything. And if you do that well, if you don't overuse any, you get some really cool downstream effects where as you're trying to write new code, it'll tell you exactly what it is that, the type of things expect. So for example, let's say I want to do this dot lookup and I hover over it. I can actually see here that the suggestion is telling me that lookup takes just one argument, which is a string. And when you get into the groove of this, any code that you would write, it's sort of like the documentation is already there for you. As well as if I'm going to pass something wrong into here, let's say I'm going to say it's true. Now I can hover over here and I can see, ooh, I'm passing the wrong kind of thing into lookup. When you're working on small code bases, you might think like, that's not that important. I can just look at it myself. But once you're in a project such as Cardstack, which has hundreds of files, and you want to make a refactor, maybe the semantics of a function are kind of bad, or you want to swap out what its behavior is, all of a sudden you have to really scrutinize every single instance where that function is being used to know if you can truly replace it safely. A good test coverage will help you to an extent, but when it actually comes to doing the refactor, if someone imports a function as a different name and is then calling methods on it, you've got quite a long way to trace through that tree. Whereas here, I could rename this and have it show up in other places. So now everywhere, for example, that I'm using the word lookup is now lookups. And if I'm using the wrong name for it later on, it'll be very clear. All right, so I'm going to put that back how it was. And I'll get rid of that example. So how do we actually do these typings? When you're importing outside libraries, you can actually import the types. There's a website. Yes, you can visit Definitely Typed to look up what types are available for your, given library. So for example, let's say I needed Moment. Moment's a very popular library with tons of APIs. I don't have to write the typings for Moment. I can just install Moment's typings from here. So let's see, for example, Moment. So there's Moment and all of its various plugins that can come along for the ride. And since this repository has already been set up with some TypeScript config, all I have to do to start benefiting from those types is just to begin, just to install it using yarn or npm. So let's go back over here and actually work through the rest of these. Okay, let's do this registry injections. Register declared injections. So I want to see where this is actually being used. So I'm passing in something called this. I'm passing in an identifier, which I can see an identifier is a string. So I think I'll go ahead and say that this is a string. Cool. And if I look back up here, factory definition. Okay, so here's what I was doing earlier is this registry class extends the Glimmer registry, which is an external third-party package. When we called super here in the register function, I'm actually able to see what it expects. So super is a class of registry, and since we're calling super, we're leaning on the behavior of the base Glimmer class that we're extending, and I can actually hover over their register method to see what kinds of types it is. So earlier on, I was able to use this kind of just hover and inspect method to come up here and fill in what the details are. We can see that factory definition extends from the factory definition typing. So for example, if I take this out, I start typing factory definition, I can tab complete and add that type in here. And in cases where something needs to be imported, if you do the tab complete, it'll actually add it up here into your import statements. All right, so factory definition, we know that register declared injections, the third argument is a factory definition. So register declared injections, factory. All right, factory definition, and I know that from inspecting the use of super.register up there, that factory definition can be anything. Now, any here in this example, it isn't being lazy. It's not saying like, oh, I don't feel like declaring what the types are. It's that a factory can return all different types of objects, just, different shapes of data just by, its purpose as being a factory. And so you can't necessarily know things like what the key value pairs and types are going to be if a factory returns an object, for example. And so it's appropriate here to say that the factory definition is any. Okay, so I'm working on register declared injections. I need to know what the type of registry is. So I'm going to go back to where register declared injections is used. I can see that it's referencing this .registry, which is something that extends type registry reader. So I know that if I go to my function, I can say that the type is registry reader. And now anyone who is using this function can actually see what kinds of things it expects to get. And if we want to know exactly what's going on within a registry reader, I can go to the definition and see what exactly a registry reader is made out of. So again, if you've worked on an app of any particular scale, you might be familiar with having these functions that just, they just take objects. And if you want to know what kinds of objects go into it, you've got to either hope that someone wrote the documentation well, or you've got to hunt down every place that function is used to see what kinds of things that they're filling into that object. Whereas here, I can actually just look to see what's going on with it. All right, so that's it for now. Again, depending on what kind of JavaScript files you're working in, adding typings could be something that kind of requires some more in-depth knowledge of the functionality that, particular package is using, or if it's code that you've written and you aren't pulling in a ton of dependencies, it could be something that you are able to just add more to. One thing I've noticed while, working on converting this file to types is that the more that a file relies on external sources like third-party packages or it's inheriting from other classes that are created somewhere else, the harder it is to convert it to TypeScript. So what I would recommend is for your first TypeScript exercise to choose something that doesn't have a ton of dependencies or inheritance from other things, and try to walk through adding the typings. Basically, the way to think about it is that everything, whether it's a function, or it's a primitive, or it's an array of items, everything needs to have a type in order to make TypeScript happy. So once you have reached that point, though, you start to get into this cascade where you stop having to declare and define types all over the place because you've done them earlier on or at the right level, and you get from this point where it's like you're investing that effort to figure it out every time that you're looking at the function. You invest that effort once to convert it into its types, and then every time thereafter that you want to use something, it's as easy as just hovering over that particular method or function or constructor to see what it needs. And I've already seen how this really accelerates development. So thanks for listening. And if you have any TypeScript suggestions, you can always reach out to me. I'm just learning, so I would love to hear what your favorite tutorials are. Thanks. Bye.